So progressing from our Bohr diagrams, we're going to talk about Lewis diagrams. Now, Lewis diagrams can also be called electron dot diagrams, or they call them Lewis electron dot diagrams, okay? So this can also be called electron dot. So if you see either of these terms, they're the same things. Now, the scientist who invented these Lewis diagram, well, his last name was Lewis. When he was first making these, he made them because he thought, well, the center of the atom doesn't react, the nucleus doesn't react in a chemical reaction. The inner electrons don't react. The only things that react are those outer energy electrons. So what energy shell electrons? So why are we drawing everything out all the time? Why don't we just make life easy and just talk about the outer energy electrons? Of course, other scientists laughed at him because they were like, oh my gosh, that's the dumbest thing I've ever heard. Meanwhile, it's like so much easier to do that. So a lot of people had to take their words back. So the Lewis diagrams are so simple. I'm going to do this whole sheet with you because you're going to see how simple they are. What we're going to do is we're just going to use the symbol, and then all we need to show is the outer electrons because they're the only ones that are involved in the chemical reactions. So let's start with hydrogen. What we can do is we're just going to label as one because we're going to do this on chart form. So our inner core is hydrogen, and then we're going to put one electron in the outer energy level. Alrighty, we'll skip over here to helium for number 2. So helium, its core is helium. We know there's 2 protons, we know there's 2 neutrons. We don't need to draw that out every time. And we also know that there's 2 electrons in its outer energy shell. And remember, this outer energy shell here is fulfilled, so helium is not going to be reactive. You can fill your balloons up with helium and they're not going to go on fire if you have a birthday cake with candles that are burning on it. That actually happens in some places. They actually buy hydrogen balloons because it's a lot cheaper than helium, and then they end up having a big fire at a birthday party. Okay, so the next one is number 3. All right, we know the core is lithium. We know there's 3 protons in the nucleus. We know there's 4 neutrons. So all we need to know is, if we were in class, I would say, how many electrons are in the outside here? And someone would say, oh, there's 1. And I'd be like, yes, you are correct. Alrighty, so next one is going to be number 4. This is our beryllium. And we have 1, 2. Then we have our boron, which is number 5. And we have 1, 2, 3. All right, we've got our carbon in here. This is already in here because a lot of times this is an assignment in class. So number 7, we've got our nitrogen. And 1, 2, 3, 4, 5. So you can see the pattern across here. 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons. Our next guy here is going to be our oxygen. 1, 2, 3, 4, 5, 6. 2 unpaired electrons there. These unpaired electrons can cause a lot of trouble for us. All right, they're the reason why things react. Alrighty, and then we want our fluorine here, and we've got 1, 2, 3, 4, 5, 6, 7, and there's our one electron that doesn't have a partner, and it's going to be mad. All right, our next one, our neon. 1, 2, 3, 4, 5, 6, 7, 8. Alrighty, and that's got a nice filled outer energy level, so it's not going to react, it's not going to explode, it's not going to go on fire. It's just calm, cool, and collected. You can use it in lighting and zap the electricity through it, and no problem. Okay, our next one here is going to be number 11. It's sodium. Alrighty, and we don't really need to think about this too much because it's in row 1, and it has 1 electron in its outer energy level. Column 1, sorry. All right, our next one is magnesium. It's got 1, 2. Then we've got our aluminum. 1, 2, 3. All right, our next guy is our silicon. 1, 2, 3, 4. Now I forgot to number these guys here, but number 12, number 13, number 14. What's nice about the elements in this row is the number kind of tells you, well, it doesn't kind of tell you, it gives you a hint at how many electrons are in the outer energy level. That's only for this row though. Our next guy is 15, and we've got our phosphorus here, and 1, 2, 3, 4, 5. All right. Next to this is our sulfur. 1, 2, 3, 4, 5, 6, and it's number 16. Number 17 is our chlorine. 1, 2, 3, 4, 5, 6, 7. Uh-oh, another really, really reactive element. And then next to that we got our calm, cool, collected argon. 1, 2, 3, 4, 5, 6, 7, 8, and it's number 18. All right, we got 2 more to go here. We've got number 19, which is our potassium. All right, and it's got 1. And then we've got our calcium, all right, and it's got 2. And again, if we go back and number our columns or our families, we have 1, 2. And remember, we're skipping over because we're taking all those metals that are in the center, we're skipping over them. We've got 13, 14, 15, 16, 17, and 18. All right, so that's how we do our Lewis diagrams. Makes life a lot easier. You're going to be using Lewis diagrams when we talk about forming ions. Alrighty, so if you need to replay this video or with any of the videos, again, feel free, stop them as many times as you want. You're fed up with my voice, just stop the video and come back later. Do what you need to do in order to go through this. Alrighty, email me if you have any problems.